My dear students, thank you for subscribing my channel. Can we start? First question. Which of the following reactions are disproportionation reactions? Which of the following reactions are disproportionation? Already explained clearly, disproportionation reaction means in a redox reaction, same element undergoes both oxidation and reduction process, then the reaction is considered as a redox disproportionation type of redox reaction. In the first equation, same element undergoes oxidation as well as reduction. So first equation is a redox reaction. In second equation, same element undergoes oxidation and reduction. So second reaction is also disproportionation reaction. Third equation, same element undergoes three different oxidation state, but both are reduction process only. So this is not considered as a disproportionation reaction. Fourth one, reaction, reverse of disproportionation reaction is called comproportionation reaction. So first option is correct option. Next question, calculate the oxidation state of phosphorus in the following elements. 4 plus 2x minus 14 is equals to 0, x is equals to plus 5. 4 plus 2x minus 10 is equals to 0, 2x is equals to 6, x is equals to plus 3. 4 plus 2x minus 12 is equals to 0, 2x is equals to 8, x is equals to plus 4. Third option is correct option. For electron in 2s and 2p orbitals, the orbital angular momentum values respectively are. Orbital angular momentum is calculated by using the formula h by 2 pi into square root of L into L plus 1. For s orbital, L value is equals to 0. So h by 2 pi square root of 0 into 0 plus 1. That is equals to h by 2 pi. For 2p orbital, p orbital L value is equals to 1. H by 2 pi square root of 1 into 1 plus 1. That is equals to square root of 2 h by 2 pi. Second option correct option. Which one of the following set of quantum number is not possible? L values are from 0 to n minus 1. Based on this, the value of L is always greater than n. M values are from minus L to plus L including 0. The value of L is less than or equals to M. Sorry, the value of L is based on this. Third option is wrong option. Possible M values are from minus L to plus L including 0. That means minus 1 plus 1 0 is possible. 2 is calculate the number of radial nodes of 3p orbital. So calculate n value for 3p orbital is 3, L value is 1 and minus 1. 3 minus 2, 1. First option is correct option. Pairs, the central atom exhibits sp2 hybridization. Straight away second option. In the BF3 molecule exhibits sp2 hybridization. Even NO2 minus is also exhibits sp. When psi A and psi B are the wave functions of atomic orbitals, then sigma star represented by what is given, sigma is equals to psi A plus psi B, sigma star is equals to psi A minus psi B. Second option, correct option. The following NH3 molecule pyramidal geometry or trigonal BRF5 BRF5 is square pyramidal A3 B1 A3 B1. Third option is correct option. Which one of the following molecules has maximum dipole moment? To 0. Even NH3 also mu value not equals to 0 because a lone pair of electrons are present. Here lone pair of electrons are absent, so the value of mu is equals to 0. And one more thing, it is a symmetrical molecule. For symmetrical molecules, mu value is equals to 0. Maximum dipole, we can break the bond. Electrons are always moves towards more electronegative element side. Nitrogen, fluorine, electrons are moves towards fluorine side. Nitrogen lone pair, electron is moves towards lone pair side. NH3 break the bond among nitrogen and hydrogen. Nitrogen is more electronegative element. That's the reason electrons are moves towards nitrogen side. In case of NH3, all the electrons are moves in single direction. But in NF3, electrons are moves in opposite direction. Maximum dipole moment is the question. So fourth option, correct option. Assertion, pH3 has lower boiling point than NH3. Correct. Reason, in NH3 molecules are associated through van der Waals forces. No, wrong. NH3 molecules are associated through hydrogen bonding forces. Assertion is true, but reason is incorrect. Electronic configuration of four elements A, B, C, D are given below. Which one of the following is the correct order of increasing electronegativity? We know that periods left to right, electronegativity value is decreases. Sorry, periods, in periods left to right, atomic sizes decreases, negativity values increases. Based on the electronic configurations, the elements are carbon, nitrogen, oxygen and fluorine. Left to right, electronegativity increases. So the correct option, fourth option. The successive 5 ionization energies of an element are given. By using the above values, predict the group in which the above element is present, where the sudden jump, where the energy increases abnormally from third value to fourth value. Third value to fourth value, energy difference is more. So the element belongs to third group, 3A group, or 3A group elements are also called as group 13 elements. Suppose if the energy difference is more between fourth and fifth, element belongs to fourth group, like that. The increasing order of the ionic radii of the given isoelectronic species. Already discussed in isoelectronic series, ionic radius is directly proportional to negative charge and inversely proportional to positive charge. So here question is increasing order starts with low to high. So low charge, more positive charge, ionic size. Based on the third option, correct option. For the reaction is given. What is the value of Kp by Kc? Kp is equals to Kc RT power delta N. Kp by Kc is equals to RT power delta N. So delta N is calculated by using the formula Np minus Nr only for gases. Number of moles of gases products 1. Number of moles of gases reactants 1 plus 1 by 2, 3 by 2. So minus 1 by 2. RT power minus 1 by 2. Correct option is third option. Equilibrium. N2O4 gives rise to 2NO2. The concentration of N2O4 and NO2 at equilibrium are 4.8 into 10 power minus 2 and 1.2 into 10 power minus 2 mole per liter respectively. The value of Kc for the reaction is Kc is calculated by using the formula PPC by PRC, product of product concentration by product of reactants concentration. NO2, 2 moles are there. That's the reason whole square by N2O4 concentration. NO2 value is 1.2 into 10 power minus 2 whole square by N2O4 concentration is 4.8 into 10 power minus 2. So 1.2 into 10 power minus 2 into 1.2 into 10 power minus 2 by 4.8 into 10 power minus 2. 10 power minus 2, 10 power minus 2 cancel. Now you can simplify. Simplify, then you will get 0.3 into 10 power minus 2, or it can be written as 3 into 10 power minus 3. Second option, correct option. Reaction equilibrium. 2 moles of SO2 plus O2 gives rise to 2 moles of SO3. Delta H value is given as negative. Delta H value negative, the reaction is considered as exothermic reaction. Exothermic reactions, low temperatures are favors. For exothermic reaction, low temperature is favors. And take the reaction from left to right, number of moles are decreases. So volume also decreases. Volume decreases, then pressure is increases. Left to right, number of moles decreases. Number of moles decreases, automatically volume is also decreases. If volume decreases, pressure is increases. Correct option, third option. 50 ml of 0.1 molar NH3 is mixed with 10 ml of 0.1 molar HCl. Then what is the pH of resultant solution? Calculate pH of resultant solution. Okay, pKb value is given. pKb value is 4.75. According to the reaction, HCl combines with NH3, then it gives NH4Cl. Here HCl is a strong acid and NH3 is a weak base. Calculate number of milli equivalents HCl. Number of millimoles of HCl is 1 mole. How we can calculate number of millimoles? Given molarity is multiple with volume in ml. Number of millimoles of NH3 is 5. So number of millimoles of base is more compared with number of millimoles of acid. Okay. 5 is also written as 1 plus 4. 1 mole of acid is reacts with 1 mole of base, then it gives 1 mole of salt. 1 mole concentration of salt. So acid base in base 1 mole is already reacted. Remaining how many moles of base is present? 4 moles of base is present. Now POH is equals to, what is the pKb value? pKb value is 4.75 plus log of salt concentration 1 by base concentration, because it is a basic buffer. How it is basic buffer? Here given hint. By 1 mole is out of 5 moles, so 1 mole is already reacted, remaining 4. That is equals to 4.75 plus log 1 minus log 4. Log 1 value 0 minus log 4 value 0.6020. 4.75 minus 0.600, you will get nearly 4.1. This is pOH value. Now calculate pH value. pH is equals to 14 minus 4.15. That is equals to 9.85. Correct option, third option. What will be the solubility product of AX3? AX3, you can dissociate A3 plus 3x minus. Number of moles of cation is 1, that is assumed as x. Number of moles of cation is y, 3, that is assumed as y. So 1 power 1, 3 power 3, s power 1 plus 3. 27. Correct answer is first option. How many significant figures are present in 0.0000135? How many significant figures are present? 3. Because if the number is leading zeros, those zeros are not significant. Percentage of Se, atomic mass, is also given. Peroxidase anhydrase enzyme is 0.5% by weight. Then minimum molecular mass of peroxidase anhydrase enzyme. Percentage of element is calculated by using the formula mass of the element in a molecule divides with molar mass of the compound into 100. Mass of the element is given as 78.4. Calculate molar mass. Percentage is given 0.5% into 100. Then x is equals to 78.4 into 100 by 0.5. You can simplify, then you will get 1.568 into 10 power 4. For the redox reactions, redox reaction is given the correct coefficient of the reactant. First calculate oxidation state of chromium in Cr2O7 2-, that is plus 6. Oxidation state of chromium in Cr3 plus is plus 3. Oxidation number difference is 3. Reactant side 2 chromium atoms are there, so multiple with 2, 3 2s are 6. Oxidation state of iodine in I minus is minus 1, in I2 is 0. Oxidation number difference is 1. Now exchange the coefficients, exchange the n factors. 1 mole of Cr2O7 2-, 6 moles of I minus plus H plus gives rise to Cr3 plus I2 plus H2O. Now balancing the reaction. 6 iodines are there, so 3 moles of I2. 2 chromium atoms are present in left side, so right side multiple with 2. Total charge plus 2 into 1. Sorry, hydrogens also balance. 2 hydrogen atoms. Before that, how many oxygen atoms? 7 oxygen atoms. Take 7 moles of H2O. Right. Now charge plus 2 into 1 plus 2 minus 1 into 6 minus 6. Here total charge is plus 6 plus 6 minus 2. Difference is minus 4. Check it once. Sorry, here this is Cr2O7 2 minus. Cr2O7 2 minus. Now oxidation number minus 2 minus 6 minus 8. Now balance the charge also. 14 multiple with 14 plus 14. Minus 8 to plus 14 difference is plus 6. Charges also balanced. So the correct option is first option. Sorry, correct option is second option. Consider the reaction N2 plus 3 moles of H2 gives rise to 2 moles of NH3 carried out at constant temperature and pressure. If delta H and delta U are enthalpy and internal energy changes for the reaction, which of the following expression is true? Calculate value of delta N. Delta N is equals to Np minus Nr. Only for gases. Number of moles of gases products 2. Number of moles of gases reactants 4. 2 minus 4 minus 2. Delta N value is equals to negative. Then delta H is less than delta U. Third option is correct option. The entropy change involved in the isothermal reversible expansion. Entropy change involved in the isothermal reversible expansion of 2 moles of an ideal gas from a volume of 10 dm cube to a volume of 100 dm cube at 27 degrees Celsius is. For isothermal reversible expansion, entropy is calculated by using the formula delta S is equals to Nr ln V2 by V1. We get 1 ln is equals to 2.303 log. Number of moles is 2 moles. R value. Here answer is given in terms of joules. So R value take in terms of joules 8.314 into 2.303 into log of V2 by V1. Final volume is 100. Initial volume is 10. Log 10 value. Log 10 value is 1. Now simplify 2 into 8.314 into 2.303. Then you will get 38.3 nearly. Fourth option is correct option. The heat of combustion of carbon and carbon monoxide. Heat of combustion of carbon monoxide values are given. Heat of formation of carbon monoxide. Formation of carbon monoxide equation is C plus half O2 gives rise to CO. Delta H. Carbon undergoes combustion, then it gives CO2. Carbon monoxide undergoes combustion, then it gives CO2. Heat of formation of carbon monoxide is question. That means carbon monoxide must be in the form of product. In the second equation, carbon monoxide is in the form of reactant. So reverse the second equation. CO2 gives rise to CO plus half O2. Reverse the equation, then change the sign. Plus 283.5. First equation as it is. CO2 cancel. Half O2 shifted to left side. Then C plus half O2 gives rise to CO. The value of delta H is equals to minus 110. Second option. What is the correct IUPAC name of the compound? Okay. Here COOH group is high priority group. First, follow the lowest sum rule. So clockwise direction numbering 3, 4, 5, 6. Follow the alphabetical order also. Hydroxo starts with H. Bromo starts with B letter. Nitro starts with N letter. So alphabetical order B is first. 3 bromo, 2 hydroxy, 5 nitrobenzoic acid is correct answer. How many different stereoisomers are possible for the given molecule? In the given molecule, one chiral carbon atom is present. Around this carbon, 4 different atoms or groups are present. So this is considered as a chiral carbon. Chiral carbon atom is present. D and L isomers are possible. And one more thing, alkene. This is which alkene? Same type of atoms or groups are present in same side. So this is cis alkene. Cis is possible means automatically trans also possible. Total possible number of isomers is equals to 4. The given compound, the number of 2-degree carbon atoms is 2-degree carbon. If carbon atom is directly attached to only one carbon, that is considered as 1-degree carbon. Carbon atom is directly attached to 3 other carbons. This is 3-degree carbon. Carbon atom is directly attached to only 1 carbon. This is also 1-degree carbon. This carbon directly attached to 2 other carbons. So this is 2-degree carbon. This carbon directly attached to 3 other carbons. 3-degree carbon. This is 1-degree carbon. This is also 1-degree carbon. Question is total number of 2-degree carbon atoms. Total number of 2-degree carbon atoms, only one 2-degree carbon atom is present. The correct order of stability of carbocation. Stability of carbocation. 3 degree greater than 2 degree greater than 1 degree greater than methyl. So second one. 3 alkyl groups. So this is 3 degree. 2 alkyl groups are present 2 degree. 1 alkyl group is present 1 degree. No alkyl groups are present. So this is considered as methyl. The correct order of negative inductive effect. Correct order of negative inductive effect is more, after that Cn, after that fluorine, after that NH2. Minus I effect order, minus R effect order, I think I given in grand test 2 exam. Correct order of stability of carbocation. Carbocation stability is directly proportional to electron donating group, inversely proportional to electron withdrawing group. CH3 is electron donating group. NO2 is electron withdrawing group. Electron donating group. Here, no electron donating group or withdrawing group. Stability is directly proportional to electron donating groups. Here, 2 electron donating groups are present. Strong electron donating group is OCH3 acts as strong electron donating group. So 2 starts with 2, 2 after 4, 4 after 1, finally 3. Because in 3, a electron withdrawing group is present. Select correct order of stability of alkene in the following organic compound based on hyperconjugation. Based on hyperconjugation, the stability of alkene is proportional to number of alpha hydrogen atoms. Four alpha hydrogen atoms are present. This is alpha carbon, 2 alpha carbons. 2 alpha hydrogen atoms are present. 7, 8, 9, 10. 10 alpha hydrogens are present. Here, with respect to alkene, 3, 4, 5, 7 alpha hydrogen atoms are present. Number of alpha hydrogen atoms are increases. Stability of alkene is also increases. Based on that, C is more stable. D after A after B. Second option. The stability order of +1 oxidation state of gallium, indium, thallium is gallium less than indium less than thallium. Correct. The inert pair electron effect stabilizes the lower oxidation state down the group. Correct. A is true, R is true, R is the correct explanation of A. Consider the oxides of group 14 elements SiO2, GeO2, SnO2, PbO2, CO. The amphoteric oxides are GeO is amphoteric, SnO2 is amphoteric, PbO2 is also amphoteric. So the correct option is SnO2, PbO2 here. These pairs are amphoteric pairs. Given the correct order of decreasing basicity of the following compounds, we know that aliphatic amines are more basic than aromatic amines. H11NH2 is aliphatic amine. Remaining three are aromatic amines. In case of aromatic amines, if number of aryl rings, number of benzene rings otherwise, number of benzene rings increases, then basic nature decreases. Based on that, third option. At 300 kelvins, temperature is constant. The density of a certain gaseous molecules at 2 bar is double to that of dinitrogen at 4 bar. The molar mass of gaseous molecules is, calculate the molar mass of the gaseous molecule. Okay, density, initial density D1 value 2, P1 value is given as 2, molecular weight calculate. D2 value 1, P2 value 4, molecular weight of nitrogen is 28. Now R value is constant, T value is constant. Based on that, RT is equals to M1 by D1 for first gas. For second gas, RT is equals to P2 M2 by D2. So left side terms are equal, equate the right side terms. From equation 1 and 2, 1 M1 by D1 is equals to P2 M2 by D2. Now simplify. P1 value 2, M1 value question mark, D1 value is also 2, P2 value 4, M2 value 28 by 1. 2 cancel, then M1 is equals to 2 gram per mole. Delta U is equals to adiabatic work. Why? In adiabatic process, there is no heat exchange between system and surroundings. The value of Q is equals to 0. According to first law of thermodynamics, delta U is equals to Q plus W. If it is a adiabatic process, Q value 0, then delta U is equals to W. Match the following. Lyman series is observed in UV region. Balmer series is observed in visible region. Paschen and P-Fund series are observed in IR region. First option is correct option. Correct order of pKa value for. In the first compound, no electron donating group or withdrawing group. But in the second compound, electron withdrawing group is present. Third compound, electron donating group is present. Fourth compound also, a electron donating group is present. Acidic nature is directly proportional to Ka, inversely proportional to pKa. Acidic nature is directly proportional to electron withdrawing group, inversely proportional to electron donating. So electron withdrawing group increases the acidic nature. So pKa value is decreases. 2. pKa value is very less for 2. Only one option is there, that is second option. The decreasing order of bond angles in BF3, NH3, NF3 and minus is linear, bond angle 180 degrees. BF3 trigonal planar, bond angle 120 degrees. NH3, NF3 are pyramidal, but the bond angles of NH3 is 107, NF3 bond angle is 102 only. Because bond angle is decreases, surrounding atom electronegativity is increases. First option correct option. Among the following, the number of state variable is, we know that heat and work are path functions. Heat is a path function. Remaining all energy forms, volume forms are considered as state functions. Correct answer is 3. Correct decreasing order of stability of the following canonical structures. We know that neutral molecules are more stable compared with charged species. Distance between the charges increases, then stability decreases. So based on that, A greater than B greater than C. Which will have highest enol content? First one have highest enol content. How? Because Two electron groups are present. Two electron groups are present adjacent positions. Repulsions are increases. So enol content is also increases. Identify the correct statements from the following. A and B are metamers. Correct. A and B are metamers because both are ether functional groups. Functional group remains same, but nature of alkyl group is different. B compounds are functional metamers. Yes, metamers correct. B functional isomers. This is carboxylic acid and this is in the form of ester. Ester and carboxylic acids are functional isomers. Second one is also correct. C. Compounds are homologous. The difference between two compounds is CH2 group. So this is homologous. D. Phenol and benzyl alcohol are position isomers. Wrong. Those are functional isomers. Second option is correct option. The correct order of Lewis acidic strength of boron halide. First option correct option. Because acidic nature directly proportional to electronegativity. But exception in boron halides p pi back bonding is possible. That's the reason boron iodide is more acidic. Boron fluorides are less acidic. Strong acid among the following is CF3COOH is strong acid because the order of strength of electron withdrawing group CF3 is strong electron withdrawing group. That's the reason strongest carboxylic acid is CF3COOH. Thank you.